Greetings, algebra students. Today we're going to be going over the Unit 10 performance task. It's towards the back of the Unit 10 packet. So if you can, go ahead and open to that. I believe it starts on page 69. So go ahead and go there and we will go over that. All right. Now everything I write, you should write, and everything I tell you to write, you should write. Okay. So with that, let's go ahead and get started. I'm going to share my screen here. Okay. It says, for a summer job, you work for a pool resurfacing business. You finished resurfacing the pool, and now it is time to fill the empty pool with water. There are two water hoses that you can use to refill the pool. You wonder how long it is going to take to fill the pool because you have plans with friends and you need to leave by 6:15 p.m. You decide to time the water flow of the hoses as it fills a 5-gallon bucket. The first hose can fill the bucket in 4 seconds, while the second hose can fill the same bucket in 36 seconds. The pool needs 20,000 gallons of water. Okay. So the first hose, it says, can fill up 5-gallon bucket in 4 seconds. So that's pretty fast. The second hose is much, much slower. It says it could fill the 5-gallon bucket in 36 seconds. Okay. And we can see the pool needs 20,000 gallons. All right. Well, let's take a look at part A. How long will it take to fill the pool with the first hose? It is now 2 p.m. Will you be able to leave by 6:15 p.m.? Well, the first hose can fill the 5-gallon bucket in 4 seconds. So the first hose can do 5 gallons in 4 seconds. Now I want to know, how long will it take to fill the pool? Well, the pool is not 5 gallons. The pool is 20,000 gallons. Okay, so I could set up a proportion here. That's supposed to be a G there. 20,000 gallons. And I want to know how many seconds is that going to take. So I could set up a proportion here where I'm solving for X. This will tell me how many seconds it takes to fill up the 20,000 gallon pool. So the way we could solve this is by cross multiplying. So 5 times X is 5X. Equals, and then 20,000 times 4 is 80,000. To solve for X, we simply divide both sides of the equation by 5. This will give me that X equals 16,000, and those are seconds, so 16,000 seconds. Okay, now I want to know how many hours that is, because we start at 2 p.m. Will 16,000 seconds, will that give me to 6:15 p.m.? Well, let's see. So first, let's convert our seconds to minutes. So the way we convert our seconds to minutes is we divide by 60. Because there are 60 seconds in each minute. So we take the number of seconds and we divide by 60, and that'll tell us how many minutes it's going to take. Okay, I got 260, and we'll round to the nearest minute. So I got 266.6 repeating. We'll just call it 267 minutes. Okay, so now we're in minutes. Oh, okay, well, how many hours is that? Well, if I convert minutes to hours, I again divide by 60 because there's 60 minutes in each hour. Okay, you should get 4.4 repeating, something like that. 4.45. But what I want to do is I'd rather do it in how many wholes and then how many remainders. So you could see how many whole hours will there be? Well, that would be 4 whole hours. So 4 whole hours, 4 hours, which is, as a side note, 4 hours is 240 minutes. So those 4 hours, how many minutes will I have left over? So if this 4 hours represents 240 minutes, then how many minutes will be left over? Well, that would be 27 minutes. So 4 hours and 27 minutes. Okay. Notice that's the same as saying 4 hours, 27 minutes. That's the same as 267 minutes. Okay. So if he starts at 2 p.m., so if we start at 2 p.m., and it takes 4 hours and 27 minutes to fill the pool, then what time will the pool fill up? Well, it'd be 4 hours and 27 minutes later. So that would be 6:27 p.m. So we would say the pool will fill up at 6:27 p.m. So we want to be able to leave by 6:15. So we will not be able to make it. We will not be able to leave on time to see our friends. I will not be able to see my friends on time. Okay. I hope that makes sense there. Now, the second part of the question is where it gets a little bit better. So it says you get the idea to use both hoses, because remember, there's actually a second hose here, right? There's the first hose that fills up the 5-gallon bucket in 4 seconds. Then there's the second hose that's much slower, but it can fill the 5-gallon bucket in 36 seconds. So you get the idea to use both of the hoses, the first and the second hose, to fill the pool and hopefully fill up the pool faster. Will using both hoses be enough to fill the pool in time for you to leave by 6:15 p.m.? Well, let's find out. So when the two hoses are working together, it'll take them less time, right? So the way we can solve that is we want to consider them working together. The way it's done is you do 1 over the time it takes for one of them plus 1 over the time it takes for the second one equals 1 over the time it takes for them working together. So for the 5-gallon bucket, the first hose, it takes it 4 seconds. So we do the time it takes for the first hose is 4 seconds. The time it takes for the second hose was 36 seconds, so it's 1 over 36 equals 1 over the time it takes them working together. Now, we don't know what this T is yet, the time it takes for them to work together to fill the bucket, but that's what we're going to find out. Okay, so now we want to add these two fractions together and solve for T. So when I want to add two fractions, I want a common denominator. In this one's case, I could change both the denominators to 36. So the first fraction will change, but the second fraction, it can stay as 36, so 1 over 36. But the second fraction, if I change it to 36, that means I'm multiplying both top and bottom by 9. So this 1/4 can change to 9/36 equals 1 over t is still on the right-hand side of the equation. I could add these together, so that's 10/36, which equals 1 over t. Now, like the previous one, we want to cross multiply to figure out how long it's going to take them to fill up that 5-gallon bucket. So 10 times t is 10t equals 36 times 1 is 36. Divide both sides by 10 to figure out how long it's going to take them working together. So the amount of time it takes for them to fill up the bucket working together, 36 divided by 10 is 3.6 seconds. Okay, so both the hoses working together, they'll be able to fill up the 5-gallon bucket in 3.6 seconds, which is a little bit faster than the first bucket alone, right? The first bucket alone was 4 seconds. Now with the help of the other hose, it only takes 3.6 seconds to fill up that 5-gallon bucket. So now we're going to set up another proportion. So for the two hoses working together, they could do 5 gallons. They could fill up 5 gallons in 3.6 seconds, as we just found out. So how long will it take them to fill the pool? Well, the pool is 20,000 gallons. So I want to know how many seconds is that going to take to fill up? Again, cross multiply. So 5 times x is 5x equals 20,000 times 3.6 is 72,000 seconds. Now divide by 5 both sides. That'll give you that it'll take 14,400 seconds to fill up the pool. Notice this is faster than the one hose working by itself to fill up the pool. The one hose working by itself took 16,000 seconds, but now with the help of the other hose, it only takes 14,400 seconds, much less. Okay. Well, let's figure out what that is in minutes. So to figure out how many minutes that is, we take the 14,400 divide by 60. That gives you 240 minutes. So now we're in minutes. Okay. Well, how many hours is that? So we take that 240 and we divide by 60 again because there's 60 minutes in an hour, and that'll give you 4 hours. So it's going to take a total of 4 hours. With the two hoses working together, it'll take 4 hours to fill up the pool. So if we started at 2 p.m., we'll be able to finish 4 hours later, so we'll be able to finish by 6 p.m. So remember, we wanted to be done by 6:15. So with both the hoses working together, we'll be done by 6. So will we be able to fill up the pool on time? So go ahead and answer that in a complete sentence. And will we be able to go see our friends on time? Let's go ahead and answer that. Complete sentence. So using both hoses, we're able to finish at 6. So you want to basically say that, answer the question whether or not we'd be able to finish on time and see our friends. Okay, well, that's it. I hope that made sense. And I hope you're able to get through it relatively painlessly. Just go ahead and finish that last question by answering a complete sentence. And that's it. If you still need help after this, feel free to email me. My email is ttrigg@ofy.org. All right. Well, take care, and I'll see you guys next time.